Okay, so title is maybe requires a lot of explanation. It's and I'm going to explain it during the whole presentation. So let's not waste too much time on the title. Okay, let me first of all tell. Is that? Oh, I just saw it. I've got no clue, but maybe it's with the double view. Okay. So there's still problems with the double view. Okay. So basically, it's something I've been working now almost 10 years on, and it's definitely not yet finished. It's probably the thing I've been talking most with Francis about because there are not so many people to discuss it. So why am I talking about it now? It's related to the paper Andy Clark published, which is called Whatever Next, which was actually very disappointing for me. It's, I like Andy Clark's work a lot. His extended mind was great, but then you see that he then goes to a book called Supersizing the Mind, where he analyzes it a lot more. And then you expect, of course, the next book to be a next step on top of that, but no. Whatever is next, a lot of people say that he kind of abandoned his previous work. And I had actually the same feeling with Latour's work, where you see science in action, having a good intuition, insight, and work that out. And then you got the book called Pandora's Box, which is actually, from my view, a very design book on science and technology. And I haven't seen any book similar to that, so I'm very into that book, although I hardly see any references working on that book, so I don't know exactly why that's not being used. But the next book, called Actor Network Theory, again was to me a disappointment. I had a feeling that he lost his track.
He has a book with the title, Actor Network Theory.
Yes, and that's the short title. But I've been, so I was, after Pandora's Box, I was really looking forward to his next book, and as soon as it came out, I bought it, I read it, and I was disappointed. So what is actually happening? You see that in many cases, it starts with intuition, it starts with some kind of insight, and there is a certain case being worked out. In case of Clark, that's Otto's Alzheimer problem. In case of Latour, that's looking at how the action of science is different to the experience of science. And you see them they work on top of that, so they start modeling and refining it. And then you see like a certain design moment where they try to create graphs and they try to put it in a broader perspective. But then mostly they kind of reach this glass ceiling where they don't seem to be able to work on top of the designs they create. So it's kind of something we recognize also in software development, where you also see that there's a concept planning phase, and that it's mostly there's a nice modular design being created. But then you see that some people start complaining about it because the way the architecture is created, it cannot be used for a next step. So there is this kind of architectural failure, and then people suggest like new paradigms, new ways to work on top of that. And so, I mean, if I think that in the software development, they are more used to this design thinking. And what I see is that with both Andy Clark and Bruno Latour, I have the feeling that they are at the right place with the wrong tools. And that I'm going to try to elaborate a little bit. So I think that the tool missing is design thinking. So let me go way back, which is actually some events that triggered later on the development of first the atmospheric engine and then the steam engine. Relates back to Tortilla, which is famous for what they say discovering the vacuum. So what is all this about? First of all, there was a problem with getting water out of the mines. Mines that are more than 10 meters deep, they couldn't get the water out. Even if they put more horses to pump, it didn't work. So what is happening? The thing is that they actually reached the limits of the vacuum. And I hope I pronounce this right now. Torricelli, yes, kind of did tried to create the experiment again, but instead of using water, he used mercury, which is a lot denser. And now it's not 10 meters, but it's less than 1 meter. It's, if I'm not mistaken, 76 centimeters. And then you have this, you see that on the top, you have this white area on top. But it's strange, so you have a full glass tube, you put it into the water, you turn it upside down, and suddenly there's this white space. Now, when they start experiencing this, they actually said that in the space there's ether. It's not vacuum. Why did they say that there was ether and not vacuum? Because there was this belief that you need a medium for the light to propagate through. Which, of course, later on they understood that light can go through a vacuum because it has no mass and so on. So but at the moment they were actually thinking that there is this other substance called ether that's in between there, and that's why light can propagate to it, but it's not really vacuum. And so I kind of give this example to show that they kind of, without the proper tools, they are kind of lost. So they didn't understand anything of the later field and quantum research that kind of threw away the ether all the way. But still, it's good enough to actually start developing some very new artifacts that kind of really change the world. This is the Magdeburg hemispheres that were used to demonstrate that several horses are unable to open the hemispheres. So they pumped out the atmosphere, and it's really strong. And that kind of inspired other people to start working on what they call the atmospheric engine first. That's been used for mining, and then later on the steam engine. So the thing is, these are artifacts. So how do you actually try to understand how artifacts can actually be the right tools in the right place? And I want therefore to make a distinction between system versus design thinking. So system, what is it? It's a set of connecting things that form a whole, right? So it's kind of describes how the thing is. Design is about purpose, about planning, about intuition that exists through the behavior of action. So it's about how things can be. So trying to visualize it a little bit. Okay, this is a system view of a share. All the components and how they are connected. Just a small quote. The whole idea here behind this is that it's an attempt to remove the chaotic diversity of our sense experience corresponding to a logical uniform system of thought. So you try to grasp what it is. Well, if you think about a chair from a design view, it's something very different. It's not so much about the parts, because the parts may actually become something very different. Some people, when they describe design, they talk about adding empathy. I don't know if that's actually clarifying stuff. I think it can actually create more questions than answers. But what is design actually? Design is, I don't think it's not at all a trivial question. And what you see is that as of the late 60s, there is this design science becoming growing, but it's still even today not very fully understood. I mean, when I was creating this presentation, I looked up design thinking and so on the Wikipedia. I noticed that Stanford is only in 2008 creating a course more directed to design. So what is it, right? Famous quote is, design is not just what it looks and feels like, design is how it works. What does that mean? Okay, that's a little bit general. So someone less known is Nigel Cross, who may actually, so that's a quote of him: there is a thing to know, ways of knowing them, and ways of finding out about them that are specific to the design area. Okay, so again, it's still general, but let's see. I mean, I just showed the system view of a chair and then a design view of a chair. So if you look at this image of a living system, right, of a cell, I mean, I wonder, that's the open question I'm going to try and work on. It's like, if this is a living system view, what is on the living design view? What does that even mean? So how can we look at this system from a very, very different way? So try to keep the difference between the chair in mind, You have a way of observing it, of trying to understand it, and a way of actually trying to create it. So how do you create life? That's a little bit the thing I'm going to work on. And I mean, I think that most people in all kind of design thinking and design sciences are at least, well, they kind of agree at least on one point, and that's who is the origin of the whole field, and that's referring back to Herbert Simon. But he's not really talking about design, he's saying the science of the artificial. So if design thinking and design science is referring back to Herbert Simon as the origin of design sciences, what is then the relation between design and the artificial? Okay, that's a less tricky question. And specifically in our interest to evolution, how do we understand from that artificial evolution better? And how do we better understand evolutionary cybernetics? So first, okay, evolution. Evolution is variation and selection. Evolutionary cybernetics is the idea that variation and selection creates a higher order of control, right? So, okay, so where does this artificial evolution come from? I mean, I think that the most basic case is domestication, where you see that there is this social, which is a kind of artificial evolution happening. And again, I mean, you start from something, but if you start removing the natural evolution by social evolution, you can actually go in many directions. You see that with dogs, with all kind of domesticated animals. They've been breeded for very different reasons. So that's where you get that when you move away from the pure natural, you actually go to potential and not all the way to artificial. So I'm going to try to make a distinction between what is potential and what is artificial. And to actually connect it back to our studies on evolutionary cybernetics, there is this quote of Francis when he tries to understand the difference between static entropy and thermodynamic entropy, where he gives a very different meaning of what energy is. So energy is defined as a capacity to do work, and working means making change, that is to say, exerting variation. Hence, energy can be viewed as potential variation. That's a little bit the key to me. So we see a link to what potential variation means, in this case energy. So you see that a stable configuration does not undergo variation. In order to destroy a stable equilibrium, you need to add energy. And I'm going to show cases of this, where you actually see that there is artificial evolution in physics and in other places. But before I get there, I need to go to... So we have potential variation, we still need potential selection, and that requires another entry. So potential selection, I think the best case is convergent evolution to show potential selection. Why? It shows similar features in species of different languages. It means that if you have in the same situation, very different species will actually undergo a similar kind of selection. Now there's debate in biology, like that's one of the reasons I put a snake over there, because they say like, okay, water, you have fins. Well, no, not exactly. A snake doesn't have fins, but I think you can take a more abstract view on it. If you look at it from this design perspective, you see that to actually be fit in water, you need what is called buoyancy. So your body needs to be in a certain way adapted to optimally move the water, and the snake is good for that, right? It can do that, but it actually can also move over land, which is a very exceptional design in a certain way, compared to fishes who have fins, who actually are probably faster in water. They are more designed to go faster in water. So buoyancy means actually that you kind of the body. There is a feature in the body that tells you how to move in a certain medium. So in water, you need to work with the drag. If you want to go in the air, you need to work with lift. So that's a different force, and you need a different structure to do that. For example, the first feathers were unable to fly. It's only later that they became able to fly. So you kind of see that there are some conditions before you are able to use a certain structure for moving in a certain medium. So. And on land, it's very different. It can be described as anti-inertia, and I put a crab over there because you see that it can be on land or in the water. It doesn't matter. It's about having a surface to push yourself onto. That's basically what you're doing. And I'm going to use that case later on. But first I want to go a little bit deeper in understanding what does it then mean, media as potential selection. So first of all, what does a medium mean? It's a substrate that can carry or support an interaction. That's basically what you can understand as a medium. So another way to describe it, it is what makes interactions propagate. That's what you understand as a medium. And trying to keep that in mind to actually look at a very different way of what we understand as media and understand what I like to call potential selection. So how do I got to this concept of potential selection? It's basically from McLuhan, who said that the medium is a message. Now he also only uses this in mediums like mass media and social media, where you see that mass media allows, because it's from one channel to many, you can actually harmonize, which is a positive effect of mass media. Or you can create alignment, which actually can have a very negative effect if you think about all the national effects mass media has on nationalism, for example. If you think about social media, again, you can have a positive effect. It can lead to activation. Even there, you can wonder if the activation is positive or negative effect, because the case I like most is Croydon, which was a sub-area of London. Where you see that one day it's being used by criminals to be smarter than the police, and the other day it's used by the neighborhoods to clean up the messes of the criminals, of the riots. So activation even can be positive and negative. But what is mostly negative is the gibberish, right? That way more people, like if some people Skype about like the most stupid things they do in a day, that's stupid, okay? But that's what you see. So you see that if it's mass media or it's social media, it's the medium itself that already defines the message. That's what McLuhan was saying. What I'm trying to figure out is how does that actually apply to physical, chemical, and biological mediums? How do we understand there this potential selection that the medium applies to it? So to go to it, let's have a look at one of the artificial developments in physics, and I will kind of see that there's a relation to self-organization and artificial. So in case A, you have a state in equilibrium, molecules, so this is water or another fluid, moving randomly in any direction, so that's a free flow. In case B, you see that there's energy added on the bottom. So you kind of start increasing the interactions of all the elements. So that's how you increase the variation. The interesting thing is, because this is a very specific medium, you see that the increase in variation, that's what creates you far from equilibrium, needs to create a counter force that is a self-organization, which is reached by creating these closures, these flows, these cyclical flows that become optimal ways to disperse the heat. And you get this invariant patterns. So after a while, because of the positive feedback, you kind of get all this, what is called convention cells, right? So you see that the combination of this adding the energy in a very specific medium would be different if you kind of disturb the medium all the time. So then there wouldn't be really a medium. So you get this self-organization, which I consider artificial. And in this case, the medium is a fluid. So the invariant pattern is related to motion, right? There is no footprint, which means that if the energy falls away, it actually goes back to state A. That's not very constructive. So if you look at solid artifacts, they do create a footprint. So in this case, right, so stone axe. So it's you need fixed things. So they need to be fixed connection between the elements. But the question is then, how can it be a medium? Now, in this case, you could say that it's a medium for force, in the sense that by the specific design of the artifact, you kind of are funneling the force to a certain point. So it's kind of a way to canalize it, but it's a little bit a simple case, so I want to go to a more interesting case, which is a skeleton, as what I like to call an artificial medium. So you see on the top, it's actually research from artificial intelligence, where they create this like, it looks like a skeleton, right? But there are some counterweights on it. And what it allows is that if you give it a very small push, it will keep on walking. That's the whole principle of this. So what I conclude out of it is that the skeleton is a medium for movement. So this is this inertia. What you see is that the skeleton is a framework that transforms the forces based on gravity and the way that the things are connected in such a way that you get an optimal structure for movement. So muscles become an interface. The muscles need only a little bit manipulation of the skeleton to make very advanced motion. Now it's also the case in the cytoskeleton. So the cytoskeleton is the skeleton you get inside the cell, and there it's related to the chemical values of certain areas. So some protein and some resources wouldn't be able to go from one place to another because this chemical reaction against it. So actually there's this whole railroad of cytoskeleton that's also, what I understood, created by stigmergic waves. But you kind of have the other elements that will rotate around it to move elements in the cell that wouldn't otherwise be able to move over there because of the chemical reaction against. Yeah, okay. So skeleton as an artificial medium. That's what I'm trying to say here, right? So it's a very different way of looking at medium. You see that the fixed structure is basically creating a framework that allows you to create a certain invariant pattern. In this case, it was motion. So I'm trying to actually use that to go back to more primitive things, like the very simple chemical, biochemical reactions. So again, just repeating the definition here, medium as a potential selection, it's the substrate that carries or supports in the interaction what makes the interaction propagate. That's what you need to keep in mind, right? So if you then look at certain bindings, you can also get invariant bindings in these biochemistry, even in very simple biochemical elements, like this is a benzene element there. What you see is that there's, so all of the hexagon are carbons, right? And there's to every carbon there's a hydrogen on it. So the thing is that there is actually the carbons are all connected with one, but every other carbon there needs to be a double connection. The thing is that it's internally it's unstable because it can move from the left side to the right side. You see, so and that's why they represent a benzene as a circle in the middle, because internally it's actually unstable. It's all the time moving. So the interactions are all the time moving. Now this is a very, very simple case, okay, where you see internal unstable, external stable. So a more advanced case is this one, which is called the citric acid cycle. It's a very important cycle in every cell that creates the metabolism. And what is so interesting in this case is you see that now there are actually carbon parts getting connected to the framework and disconnected at certain moments. So it becomes way more unclear that this is a framework, that this is a medium. But what you can see is that there's always these carbons that always connects all the other elements in a certain way. And then there are the reactions that makes it invariant, makes it move all the time. So and in this case, there's again this invariant pattern because at a certain moment it comes back to the same structure. And so this is a cycle that all the time goes, like there's oxygen removed as water, then the water gets back in, and so on. I'm not going to go through all the details, but it kind of gives you a view of how the medium, as carbon as a framework for a medium, changes all the time. So that's basically the essence I want to go to. And the other thing is that it creates also constructive growth. like the autocatalytic sets, allows every element in the set to refabricate the set. So suddenly the system is capable of cloning itself. And it becomes even more interesting when you get this higher order medium with nucleates. Why do you get a higher order medium with nucleates? It's because of this. Nucleates are capable of coding. So the top, okay, this is, first of all, you have DNA in the cytoplasm, right? It gets translated to this meshed RNA, which is the long string. So this is just a copy of the DNA. And then you have this ribosome, who is like an agent, moving all the time over this code, and then takes all these peptides. So all the green parts are peptides, and they have different connections. And depending on the code, they can actually connect different peptides. So this actually creates a general processing machine. This is able to code any kind of thing based on information on the DNA. So so again, nucleates can be seen as a medium. And now it's a medium for a higher, well, it's higher than the pure chemical, right? But it's still smaller than if you think about cellular. So it's what creates the cells and not yet multicellular, which are again higher levels. So I want to get back to this artificial evolution. So again, potential evolution, which is energy and medium, but it can go in any direction. And that's when you start seeing that it actually needs to be regulated by external regulators. For example, if you think about domestication, there's already another higher level agent that is domesticating, right? So you have the variety of dogs, but there is a human that has been manipulating the evolution of the dogs to create them. So there is this external force. If I think about the convection cells, right? The convection cells only exist because of the external force. So you cannot see it without this external regulation. So the real question I'm having is like, yes, but how do you self-regulate this? How does the artificial so I'm interested in a medium for self-organization. I want to understand intelligence. I want to understand the origin of life. That's the focus, right?
I still don't understand what you mean by potential selection in this framework. You explained that energy is potential variation, and you say medium is potential selection. Yes. But in your examples, I don't see the potential selection. What do you mean by potential selection?
Well, the converging evolution gives the example of potential selection, right? So depending on the medium, you get a certain amount of designs that are possible. Like if you want, like it's very clear in air, there are only few species that have been airborne, and only when they have created this lift. So in this case, so for water and for air, the buoyancy is very important. For land, the anti-inertia is very important. That's the real design features.
So kind of generalized selection criteria, but which do not select for a particular design, but for, let's say, a family of designs that may be different.
Yes.
So that is what you call potential selection.
That's a potential selection. It selects for an artificial, it selects for a design. It's not selecting for a fin or a snake structure. It's more abstract. If you describe it on a little bit more abstract level, it is very clear that the medium is the potential selection.
I want to suggest additionally to Francis' question is that every structure, if you have a structure, it is already instructive regarding the way that it can cause symmetry breaking in its environment. Mm-hmm. So if it has an extra energy, it will go in certain ways and not in other ways. Mm-hmm. And this is inherent in every structure that there is. It can be shown. So this is the potential selection because not everything goes. There are certain paths that are...
You mean like in a bifurcation where you have several possible ways that it could go, but the selection is that it has to choose one of those bifurcated.
Yes, I have simple examples. If you have two rectangles, just geometrical example, if you have two rectangles that are moving freely in on a plane, there is a certain way they can be related to each other, which is different from all other ways when they match on one side of them.
I would like to see this as the example for me. You add energy, so you from your definition, you increase the variation, right? The increase in variation creates us far from an equilibrium state. Well, so where does the self-organization come in? And where does a self-organization relate to? So, and that's what I'm saying, that
far from equilibrium means that you have to somehow dissipate the energy, and you have to find a way to dissipate that energy.
Yes, and what I'm saying is that the way it's dissipated relates to the medium. In this case, the medium is what is propagating is motion.
Yeah, it's a liquid. Yeah.
Is a liquid, and what you see is a pattern related to the motion. That's what I'm saying. If you go over here, you see that what is far from equilibrium is the chemical structure. So, and what is propagating is the reactions.
It's kind of a complicated version of the convection cycle.
Exactly.
Again, a cycle in which energy is added by some energy-carrying molecules, and the whole thing keeps itself in balance. Yeah.
But the difference is this leaves footprints.
Yes.
You mean in terms of molecules that it produces?
Yes, because after this, if you remove the energy, it goes back to state A.
Yeah,
after
the
this,
other one also would fall down if the energy.
This would fall down, but all the elements it has created are the footprints. It's a little bit like this. It's after the rocks have been forcibly been moved again. It's not used for thousands of years, so it's still lying there. But there is this footprint, and that creates
That's a nice idea. The autocatalytic cycle is different from the convection cell in the sense that the convection cell just produces energy which gets dissipated, and by definition, dissipated energy you can't do anything anymore with it. Or the other one produces molecules, and these molecules remain after the cycle has disappeared.
Yes.
So they leave traces.
And these traces, that's for me the beginning of the science of the artificial and the science of design. It's because there is some structure on it. In this case, they are already created by intelligent species. What I want to go to with this question of the self-regulation is how it can actually have started. Where does it all begin? That's the question of origin, right? So what I'm kind of saying then is that if I look at it from a design perspective, I kind of need to put the medium in the energy and the energy in the medium. I'm going to explain what I mean with that. So from energy, I will go to what I call agencies, which is specific ways of using the energy to design things, to fabricate things. It begins with fabricating. From medium, I will go to workspace. Again, workspace is going to be a little bit difficult because we are used to workspace as like, okay, this blackboard is a workspace. But then the interface to the blackboard, it's me. And I claim to be an intelligent agent, right? So whatever I put on the board is already, the interface is very important. Now, if you remove the interface by a very simple interface, do you still have workspaces? That's what I'm going to get to. I'm actually going to claim that the workspace exists before there is intelligence. That's what I'm going to show. But I'm going to do that first by focusing on the stages of artificial variation. So, which is this idea of to move from energy to agency. You want to question first?
Yes, before you
okay.
I see that you're going into deeper.
Yeah.
It's very interesting what you presented till now. Why do you choose to put like a threshold between this combination of energy and medium on one end and intelligence appears on the other end? Is it not just a continuous spectrum of happening?
See if I got your question right. Well, it is a continuous spectrum, but if you want to, like, if you think about the origin of life, yes. They question, like, what are the intermediate stages to explain how a certain development could have occurred. And if you think about intelligence and the define I'm making, it's like, I'm interested in understanding how the medium for self-organization can have occurred. So in an attempt to better understand how intelligence has emerged. So it may be strange then to talk about agency and workspaces, because we mostly see them as things that come from agents. But what I'm going to show is that in the investigation of trying to understand this primacy problem, is that I actually, when I put workspace and agency before intelligence, I'm actually able to do stuff. And that's what I'm going to try to demonstrate. Okay, so first of all, I'm going to do these stages of artificial variation, which means that you go from one certain thing, like the rock, which is an object, and there is this intelligent agent changing things on it, so it's fabricating it, and it becomes a tool. Now, I like to make a distinction between objects that become tools and niches where you create scaffolds. So what's the difference? The stone axe is a tool. It's the idea that you amplify a certain feature, right? In this case, to create force on a certain way. The scaffold, it's actually the opposite. You have a perturbation you want to get rid of. For example, you have a cave, and there's a drag to that cave, so you kind of try to put something in front of it to keep the drag out. That's draft. So that's a kind of a scaffold. Now the thing is that there is this, while there's a very clear distinction in nature between objects and niches, once you start fabricating things, there is actually a very ambiguous separation between scaffolds and tools. For example, if you create a car to move faster, which is a tool, you kind of, by moving faster, get this, the perturbation of the air. So if you look at the first cars, it was like a wagon, you were sitting in front of it, right? But then people noticed that that's really a terrible situation because you've got all the air in your face. So they start building this cave around it with glass so you can actually be protected against the wind. So you see that the tool actually requires also the scaffolding. Is a car, is it a tool or is it a scaffold? It's a tool to move faster, but it's a scaffold against the perturbation that you create by moving faster.
You define a scaffold as a protection against the perturbation?
Yes.
It's a bizarre definition of scaffold. A scaffold is normally a temporary structure that helps you to build something.
Well, that's kind of an interesting question. A scaffold is a temporal structure for the client. It's not a temporal structure for the builder. They reuse the scaffolds all the time for their next. So the thing is that
for them it's a tool.
For them it's a tool, but for the house it is a scaffold because what you try it's a protection because you don't want the house to fall down or whatever.
Well, the scaffold is not really meant to have the house not fall down. It allows you to build the house, to have something to stand on while you're building the house.
Yeah, and if you don't have it, it would fall.
No, then you wouldn't be able to build it simply, then you wouldn't be able to get up to a
Oh,
place
well,
where
yeah, I
you
mean,
can
if you just thinking for yeah, okay, but you got other kind of scaffolds too, like when you, for example, take out a house, you need to put a bar between them to make sure that the two houses stay. That's also a scaffold.
Ah, yeah, okay.
So in what you're thinking about, stelling, we say, right? It's well, it's a way to bring the agent that needs to do a certain task at a certain height, right? So okay, there it doesn't fall down. It's
so you see
all the time.
The temporary support that gives stability to something that's not able to stand on its own.
It doesn't need to be temporal. Like if I think about a cave, the door. If you create a door before the cave, that's a scaffold, and that stays there forever, basically.
I wouldn't call it a scaffold.
That's the way I define it.
The word that you choose is besides the point. But if I understand, is it correct to say that tools are meant to amplify certain signals,
Yes.
and the scaffold is meant to suppress
Yes.
or regulate? So
Yes.
it's a positive kind of feedback.
Yes.
It's not feedback, but it's
No, that's
amplification and the attenuation of a signal.
Yes.
Okay.
So what I see is that that's what you get with artifacts. So all kind of artifacts can do that. But what I see then is if you think about the artificial mediums we had earlier, like The whirlpool is an artificial medium. The convection cells are artificial mediums. The metabolism is a artificial medium. So what you kind of get is that there a bootstrapping relation exists. So what happens is that you can actually make a separation between these tools and scaffolds, an ambiguous separation. But if you look at the artificial medium, the separation becomes we cannot really separate it anymore. Why? Because it's bootstrapping. It's changing everything. And the bootstrap means that it has both scaffolding and tools features. That's basically what's happening. And that's what you see in these artificial mediums that kind of are bootstrapping some kind of features. Now, the thing that I still need to separate is these artificial mediums, they can create things, but they are still not agents. To get to an agent, you kind of need to automize. You need to kind of, if you think about the
autonomize. It's autonomize.
Autonomize, yes, autonomize. So you kind of need to find ways where you are capable to regulate it. So which means finding a way to present it as knowledge, having ways to have the sensory motoric response. That's what you kind of need to start doing. And what you see then is that something that has external states becomes a relative state, becomes a hybrid state, becomes eventually an internal state, which is the knowledge of the agent to regulate. And over here it's still not yet very relevant, but I'm going to show some other cases where it becomes relevant. So if I think about, I'm just going to finish this, right? Yes. To get artifacts in this way I define it, you actually need physical things, like the convection cells are already artifacts, the way I define it, right? To get to artificial mediums, you at least need this carbon as artificial medium. To get to actually an agent, you can see that these nucleotides that are coding, they are already kind of presenting the things as information and using the information to build things. So then you actually can start talking about agents. So you need this level of, level of what I like to call stages of artificial variation, of stages of agency. So it can fabricate, it can bootstrap, it can autonomize. That's basically the whole thing. Those are the separations, the things that become more advanced. I'm gonna do something similar, so I moved from energy to agency. I'm gonna do something similar here with moving from medium to workspace. So workspace, it's a little bit more complicated because, like I said, the blackboard is a workspace, but you need an intelligent person to put things on the workspace. So I want to go back to very, very simple kind of workspaces. Because, well, first of all, a medium has no meaning. I will show that a workspace has it. And a workspace, the way I define it again, right, only exists by external input and output. So input-output can be reached by sensory motorical coupling. And the easiest case I can think of is the Reitenberg vertical, where you see that there is a light sensor coupled to a wheel, right? And the nice thing is that that creates this cause and effect situation. Namely, if you have two of them and they are connected in a straight way, the vehicle will move away from the light. If it's crossed connected, it will charge the light like a bulb.
You should add that the more light falls on the sensor, the faster the wheel turns.
Yeah, so the
if
sensor
more
controls...
light falls on the right-hand side, the right-hand wheel will turn faster, and therefore it will turn to the left.
Mm. Yeah. So... Okay. Okay, so that's but what I'm very interested in is the sensor motorical coupling. And I'm going back to this Bénard cells because there's some interesting structure there. The first one with convection cells was with where the site was not heated, so around the circle around is not heated. They actually did some other experiments where they had specific temperatures to heat the sites. And what happens is that depending on the specific temperatures, you get a certain pattern, and the pattern repeats. So what you kind of can say is that the heat is the sensory input, while the patterns are your motoric output, right? And so this is for me the most basic kind of workspace, where the interface to it is as easy as it can get. It's just temperature, that's it, right? Harder temperature, lower temperature, yes?
You get the different patterns because of the relation between the medium and the energy, the
yes.
potential energy of this.
Yes, but and the sensory,
okay.
yeah. So that's why you get this sensory motorical coupling on a very, very low-level situation. So this is the basic workspace. So if you want, so we all know the whiteboard. The whiteboards are the advanced case. This is for me the most basic one.
But who is working in that space then? Is it the medium?
The artificial selection, yeah. The medium is the selection, and the energy is the variation, and together they form this artificial evolution, which we call self-organization. So it's a self-organization that allows us then to connect, to see that inputs and patterns get a causal relation.
Yes, there is an important point here,
yeah.
is that even if you don't eat, this medium has a fine structure, a microstructure, and what you see is when you put the energy inside, the micro variations becomes macro patterns.
Yes.
It's a change in the scale. There is a fine structure. There are atoms or molecules that have certain relations between them, and when you pump it with energy, this self-organizes in order to be expressed in the macro scale.
Yes.
What is happening here is the shift from structure in micro scale into structure in a macro scale.
Yeah, but it's kind of stable in the sense that
yes.
you can actually change the temperature and you get all these patterns. Well, I can see some kind of mediums where it propagates until it breaks, and so you don't have anything anymore. But this workspace is something that can keep on being used, like a whiteboard. After a while, you just, if it's full, you empty it again, and you can write again on it. In this case, it's a little bit the same. The selection from the medium and the variation from the energy allows you to play around with this sensory.
Now, what he's saying is that he's not so much interested in the microscopic variation, but in the macroscopic variation of the boundary conditions. By changing the boundary conditions, the distribution of temperatures, you get different patterns.
Mm-hmm. Yes.
So what you have is that the causal process here has, in a sense, two inputs. The microscopic variations that you don't see, but which get amplified, and the macroscopic variations on the temperature, which create kind of a boundary condition which allows certain forms of self-organization, but not others.
Yeah.
And so the selection will be that some of the allowable macroscopic patterns will be created, but you know that not any pattern can be created.
Yes, because the constraints in the micro dimension, not every pattern can happen here, just some pattern.
No.
This is
yeah. And what I try to get out of it from like a design perspective is that it means that in the workspace there is information. That's what I'm getting out of this. This is the most primitive form of information to me.
There is an information transmission in the sense that from the pattern you could in principle read something about the distribution of temperature on the side.
Yes, and that's for me essential to try and better understand this.
Just another question: Is there only transmission of
That's
information,
a brain, by the way,
or creation of information?
There is also creation because of
this is what interests me.
because the self-organization has a choice. It's not deterministic. There are more than one way to self-organize.
There's certain kinds of symmetry breakings that actually create information.
Yeah. And this is kind of what I then understand.
So you might call it information processing. There's
yes.
partly conservation, partly creation of
yes.
information.
But by pure physical motion, and I love that. And I use that to better understand the brain. Now, the only thing I'm saying here is, I like already to mention it, because what you see is that in this case, the pattern and the motion output are connected. There is no disconnection of those two. In the brain, of course, it is disconnected. and what it allows is way more advanced kind of information processing. I think if you go back to the nucleotides, you already see coding, but it's still not so, the input-output relation, there's still a lot more coupling with these neurons and more virtual information. You are capable of creating then more information processing. Okay, it's way more advanced. There are multiple sensors, there are advanced memories and so on. So I'm not going to get too deep into this. I need to take a step back. And I want to go to the principle of evolutionary cybernetics. There is the law of requisite variety that says that the larger the variety of actions available to a control system, the larger the variety of the perturbations it's able to compensate. What does that mean? Okay, I want to understand better how can from a self-organizing point can this kind of control then emerge? And then the law of requisite knowledge, which says that in order to adequately compensate perturbations, the control system must know which actions to select from the variety of available actions. Now, if you go back to our convection cells and the way we have worked until now, there is still a big gap before we can actually talk about the control system or about knowing which actions to select. So how do we move to that? So if you think about ways how evolutionary systems gain control. So so the top symbol shows there's a perturbation happening. There's a system that kind of closes off all the perturbations. It's very safe. But what you see is that it's not really adapted to evolve. While if you have a system with more open boundaries, you can actually see that some of the perturbations can move inside the system, but they are suppressed. So they are not the full perturbations anymore, they are suppressed perturbations. I'm going to give a simple example. If you do sports, what you kind of have is that you're making a lot of force, but you're kind of spreading all that over all your muscles. And what happens is there are going to be micro fractures in your muscles. And it kind of helps your system to learn where to improve the muscles without really breaking the whole system. It's not that one muscle falls off it. No, it's micro fractures, and that allows you to grow. That's basically what I see also on a pure cellular level, where you see then that there are all kind of things being created. Now, below, you kind of see how if you get to an ecosystem, right? So it's pretty complicated, right? But the small closed one I consider the pioneer, which kind of takes squares, push triangles, right? The bigger one takes crosses and push squares. So the pioneer can actually eat the things from the big one. So, but after a while, the open system needs to create stars to transform the triangles in the environment to crosses so it can eat it. That's basically what you can sometimes see in situations. I mean, it's inspired by ecosystems, right? But what you see is that now the two actually are in a closed loop again, and that allows them to actually become their population can grow over the initial carrying capacity of an environment. That's what you see with an ecosystem. An ecosystem, the things connected become more than the sum of the things, right? Another part is the mobilization you see. This is also what you see with cells. First, they kind of, the most primitive kind of create the enzymes in the environment. That's very wasteful. So what they start doing then is actually closing up the food, putting it in a small separate environment, transforming that environment to a workspace, and while they are taking out all the nutrients, they're actually pushing in all the waste, and then they push it back out. So you kind of see also a kind of the mobilization happening, where food is being transformed to waste. And I want to use that to create what I call the stages of artificial selection, or the stages of the workspace, which is an adaptation of the meta-system transition Francis has created. So the top one is from Francis. It's a collective. When it starts interacting, becomes a medium. A medium, when it starts coordinating, becomes a mediator. And a mediator, when it starts controlling, becomes what he likes to call a manager. That's when the moment that it becomes a meta-system. I actually removed some of the terms because mediator, I believe, is more general. And if I think about hives, I find it a little bit difficult to call a hive a manager. So instead, I suggest to call it an enterprise. I consider, if you look at a hive, it can actually look more to an enterprise than to a manager. But again, what I see is that you go from interaction to medium. I kept that state, but then when the medium goes to coordination, you also get this ambiguous separation between what I like to call an ecosystem and a mobilization system. And I will explain that in a little bit more detail later. I first want to just follow the picture. The mobilization system, when it goes to control, goes to enterprise. That's exactly what Francis is describing with the meta systems. What I'm adding to it is that the ecosystem part, when that gets controlled, can actually go to a laboratory. And I like to call that a meta-workspace. So I'm going to first explain a little bit what a meta-workspace means. There's a lot of information on this slide, right? So I'm first going to explain a little bit what is this separation, where is this coming from, this part, right? From ecosystem to laboratory. First going to explain that a little bit, and then I'm going to come back on why I call it enterprise, why I call it laboratory, what are all the other things. So okay, meta-workspace is pretty evident. It's a workspace of workspaces. The thing I'm saying is that take that in a workspace, you create some unstable structures or some rare structures. They may be unstable. So if the workspaces would be far away from each other, they would never really get to an interaction. Now, if all the workspaces are like in a closed, like in this hexagon pattern, and the elements can actually, that have been creating one workspace can interact right away with the other workspace, you kind of get this situation where very temporal elements can actually get combined. And the reason that is relevant is if you look at some of the meta-system transitions, it's very hard, for example, to explain did metabolism or closure came first. And there are so many debates about that. So that you see that the solutions they are getting to are what I see these meta-workspaces, where different things are created in very closed niches that then kind of interact, and on top of that you kind of get the bigger chance to create like the first cells and so on. So that's what I like to add to it. What is the difference between a meta-workspace and a meta-element, a meta-system? In a meta-system, all the elements are enslaved. While in a meta-workspace, the object that can be created out of it can later on, if it can, for example, clone itself, it doesn't need the meta-workspace anymore. So the meta-workspace can be redundant. The best case to think about this is like an egg, where you have the embryologic development, and after the egg, you don't need the shelter anymore. You move on. The same like if you look at the origin of life, they are searching for the environment that has been able to create first cell. But once the first cell has been created, it doesn't need that environment anymore because it can clone itself. So that's what you need to figure out, like how can we create also a meta-workspace. Now, I call this laboratories, right? The reason why is that if you analyze the way they describe in science and technology as a laboratory, you really see that it's kind of a very specific controlled ecosystem. In all of the cases, it's extremely controlled ecosystem. And what comes out of it is it starts creating a new element. And that's why I like the concept of a laboratory to explain this meta-workspace. And these are basically what I see laboratories of life. So those are two alternative cases to understand where the first cells are coming from. The left one are what is called catalytic vents.
Hydrothermal vents.
Hydrothermal, but those are not from sulfur, those are from calcium, also if I'm not mistaken.
Yeah,
Calcium.
Thermal just means that it's produced by heat.
It's produced by heat, but the specific, so what you have is that in the sulfur vents, there were many objections against the sulfur vents, which were the first to be considered as possible places for cells to emerge. This is what they call, I think it was alkaline vents, which alkali vents, yes, which turned out to have better properties related to the conditions for the self-organizations of the first cells. Now, this is actually only discovered in 2010, so you see that it's pretty recent research. It's called the Lost City, and so it's still very. They still need to do a lot of experiments to see.
Deep under the ocean.
Don't know the location anymore. It's called Lost City, and it's called Alkane Vents, so you can probably find Alkane Vents.
I think they remember it was somewhere in the middle of the Atlantic.
Probably. I don't know. It's at least a spot they didn't yet explore until 2010. Now, the other one, it's also very interesting. It's more a change from the perspective, in the sense that this is foam, yes, foam from the sea. And what you kind of see is that the foam of the sea can have these closures while it's actually rolling over a surface. And there can be what is called a surface metabolism. So they've understood that on a surface there can be a metabolism. And the thing to make this work is that you need to take into account the early stage of the Earth, which at that moment the radiative shield wasn't strong. And so there's actually a lot of radiation here, radioactive activity. And that would actually break down the foam and the metabolism structures, and that would create the far from equilibrium, very specific on that spot, that may actually be the place where the first cells have been created. So there are alternative cases, but independent for me doesn't matter. I can see both of them as a lab. I see in both cases that there are many workspaces where things are connected, where temporal structures are created, and that if the temporal structures would actually lead to the self-organization, then you get, by the cloning, suddenly a boom in production of cells. So,
what I understood is that the big problem in the origin of life is that you need a lot of molecules to react with each other, and if you do that just in the ocean, it's much too diffuse. The probability that all the right molecules would be there at the same time is very small. So what you look for is something that creates surfaces where things are much more concentrated.
Yeah.
And these are possible ways of surfaces where you can concentrate a number of organic molecules so that they can interact with each other on a much more focused way.
Yeah, actually, yeah. Well, there are some things I would love to explore, because what you said is like the resources from many places in the world needed to be connected together. I wonder if there wasn't already a mobilization system on a very larger scale that would have been able to put all the resources into this meta-workspace.
I suppose there would already have been oceanic currents like the Gulf Stream equivalents that would have brought resources from many different places.
So if you start describing that, you can actually come to this concept of this meta-workspace.
But you would need something that kind of attracts the molecules to it so that they somehow stick together. Because in the ocean they would be too diffuse. So these kind of structures typically, I suppose it has to do with adhesion. If you have something with a lot of surface, lots of molecules can can stick to the surface, and like that be both much closer together than they would be if they would be just in the water.
Yeah, and if you then have, like in this case, a vent that kind of disturbs it and then creates the far from equilibrium state, or in that case the radioactive effect, you get also this far from equilibrium situation. You get to this interesting situation. So these are for me the labs of life, right? So this is a laboratory in my definition. Why? Because if I go into science and technology, the only thing that really happened is that there are more intelligence elements creating these structures. But the things that's been created, the potential variation and potential selection that are happening are in a certain way similar. That's what I'm trying to get to. So that's why I'm coming to these two things for the artificial evolution, where you have on the one hand this fabricating, bootstrapping, and autonomizing, and on the other case the interacting, coordinating, and control. So I'm going to go a little bit more in detail now to this ambiguous separation. Now, going from niche to scaffold and from object to tool, that was easily explained, right? It's amplifying something or it is perturbating something. To better understand the ecosystem and the mobilization system, it's better to actually work in the other way, other direction. The laboratory is capable of, in this meta-workspace, of making sure that it's a very controlled situation. So what is actually happening in the ecosystem already is that the ecosystem is already creating a new element. But it is not really fixed, defined. It's not standing on itself. Without the ecosystem, the element would not exist. In the laboratory, by the control of all so the coordination now becomes control, it actually creates new elements. That's the difference. While the ecosystem is already a new element, the laboratory creates it as an independent element, and then allows you to bootstrap. I will show that in more detail.
I still don't get the difference between mobilization system and ecosystem.
Well, I can explain now the enterprise. So what you go with mobilization enterprise is that the enterprise creates a new niche by resource allocation, by all kinds of things. If you think about enterprises in for example, enterprises creating the electrical grids, you kind of transform the whole environment. If you think about early enterprises for trading, they transform the whole environment. So that's on the social fabric. I will come back to that later. So but what you see is that the enterprise is capable of transforming the whole system and therefore creating a new niche. What you actually see with the mobilization system, I have mobilization system more the way that Latour defines mobilizing the world. And what he described with mobilizing the world is, for example, if you take all the bones from archaeological findings from dinosaurs and you put them all together, you can actually recreate the Jurassic period and better understand also how they interact and how they relate by bringing all the resources to one same location. So you see that you create a new niche. That's what's happening over there. Now, in case of the musea, what you see is that after all the resources are brought together, the mobilization is actually not needed anymore, right? The system exists. It's a little bit like the Stone Axe. You don't need the things anymore. So if you think about a system where when there's no mobilization, there would be no system, I think you better look at cities, because big cities, even most ancient cities, they wouldn't exist without the mobilization they create. So they have a lot of input, they have a lot of output. A body is even more complicated, but a body is a meta system, right? I think that a city, it's not yet that advanced as a meta system, but you do see both, on the one hand, the ecosystem aspects of a city. Right, there is the district for the financial district. There is the problem.
Oh, you have a question.
Question. Go ahead.
About the previous slide, I guess.
Previous.
Yeah. So these little rectangles, it's very difficult to think about as sort of entities, different entities.
The rectangles.
Yeah, but it's easier for me to think about them as sort of functional aspects of the same, whatever, workspace or whatever you call it, framework.
Yeah, well.
So how do you define these rectangles? Because you didn't say this. What are they? Are they like agent? Is it something, an entity which is different from the medium?
So the agent from the artificial medium, yes. The thing is that the artificial medium, so the difference is this, you see how this external state becomes internalized. In case of the artificial medium, which kind of catalyzes the whole thing, you kind of see a change from the whole situation, but it's not in control of that situation. While if you go to an agent, it's with the internal state that the agent can select actions, so it starts getting into control of things. So that's the difference between those two. Now, if you look at the dotted line, for the artifacts and the workspace, I actually make the dots between both of them, because I'm saying that you cannot actually look at one without seeing the other. It's relative. It's ambiguous.
So there are aspects of the same kind of system or function.
Yeah. It's like a stone axe is a tool, but at the same time, you can probably. I'm sure you can find ways to describe it as a scaffold. And that's the same with the ecosystem, the mobilization system. It's one same entity. You cannot see an ecosystem without a mobilization system. You cannot see the mobilization system without the ecosystem.
So it's different functions or aspects.
Yes, and they become absolute in the next. So they they were absolute when they were objects and niches, and they become all the time more similar when you go to those transitions. While in the transitions from so that's the artificial. That's artificial variation. Strange enough, the artificial variation makes the difference between niche and objects less all the time, while the artificial selection kind of makes the separation more and more. Where you see that at the workspace there is no separation, but when you go to control, you can actually see a very clear separation between an enterprise and a laboratory. Not clearer, let's say. Clear.
What's the difference?
What the difference is what this enterprise is exploiting while laboratory is exploring, something like this.
Well, the thing is, well, that was city. You kind of see it better when you go to the way the novelty gets into the whole picture. It's an enterprise creates a niche, while a laboratory creates an object. That's the whole thing I see emerging. And if you look at the collective, it can be artifacts and agents all together. It's that all together they form they have a shared states, and so there's something more than if they are separate, right? So that's a little bit default by aggregation. While on the other hand, the enterprise creates a niche. Mostly that's the final stage. Like, okay, a beaver creates a dam, the environment changed, and that's it. It's very rarely that you see that there is also a meta-workspace that is capable of creating new objects and kind of transforming the whole game to another level. Like, suddenly there are cells, well, suddenly it's a game between cells. Suddenly there are multicellular, it's a game between multicellular. And now, with our work on the global brain, you see that probably the internet is this laboratory creating new objects. And you kind of get to a new level of the game. So without, and that's a little bit the observation I'm getting, is that to get to a phase transition requires a meta-workspace. To get to a meta-system requires internalizing the workspace. So
I still don't get the difference between an enterprise and a laboratory. Could you explain?
Yeah, this is the difficult point.
That's the thing. The enterprise creates niches. The laboratory creates objects. That's it.
So by definition, the enterprise is that what creates niches.
Yes.
So if we understand the difference between niche and object, which I'm not 100% sure, but at least it's more clear, then I can in principle deduce the difference between enterprise and laboratory.
Yeah. And if you think about like the science and technology, you see that enterprises, the enterprise around electricity, the enterprise around trading with the East, the enterprise of, an enterprise is a hard to undertake
undertaking.
Undertaking, yeah. Undertaking. Well, that's why I got stuck. So we know them best as economic enterprises being companies, but there are other enterprises. But what you see is, like, for example, the one with electricity. Okay, there's a lot of company, there's a lot of businesses involved at the moment.
Would it be correct to say that the niche you mentioned before, a few slides before, more at the beginning, you made a distinction between, I don't remember the words that you use, something which amplifies, like a tool, and...
Oh, wait, it's here. So the tool amplifies and the scaffold is...
So, niche is something in the category of scaffolds and objects is in the category of tools. Is it correct to make this analogy?
Yes.
So the niche is made, if I examine the relation between a niche and an enterprise, the niche is supposed to create a favorable environment for the enterprise.
No, the enterprise creates the favorable environment
for itself.
For itself, yes. So the niche is the favorable environment for the enterprise.
Well, it's kind of the
suppose I am a company, and when I create a market, to my products, it's a niche.
Yeah, but if you like the enterprise around electricity, you see that it's creating the grid itself that was the undertaking, and the changed environment afterwards is kind of the spillover effect of that enterprise. And you have that with many innovations. What you see is that there's an innovation and there's a kind of an attempt to exploit it. And then during that exploitation, there is a spillover effect. So I would see the niche as a spillover effect. I mean, the internet is a spillover effect of many interactions that have occurred around certain specific problems, like working in CERN, working in universities, working in the military, and you see that they start connecting, and so the enterprise, the internet is a niche as a spillover effect of enterprises dealing with information processing.
But so enterprise is related to mobilization system. Mobilization system, as I understand by definition, is something direct, and ecosystem and laboratory is something like trial and error, variation thing. Something gets out.
No, what you see is that in the ecosystem, so that's a little bit what I try to show over here. The left over here, you see that by the closure, those two elements can actually grow over the carrying capacity of the environment. So by creating the ecosystem,
that they going over the carrying capacity means that they consume more than is available, or they produce more than can be absorbed.
So there's a limited amount of resources in the environment. By creating this closure, they only depend on each other to grow. If we grow more vegetables, we can have more people. It's basically what you see with agriculture situations. So you see that there's a closed relation between what you try to produce and the ability of your self-reproduction, basically. So in this case, you see that with a lot of cells. I mean, if you think like the first feeding cells.
The ecosystem is essentially closed apart from sunlight entering, but all this is getting recycled.
Yes, and the scarce resources become optimally used. But you see that where at the beginning they may not have grow over a certain amount of population, that by adapting to a synergetic relation with each other, they actually are capable of growing to a larger population. Yeah. And that's what I mean with that there's a new object being created. The object being created already exists with the ecosystem. So with this one, in the ecosystem, there is already a new object being created, being the ecosystem. But in the laboratory, they push it one level ahead, namely that there can be an autonomous object being created. Like the first cell, that once it's created, it's capable of cloning, and it exists outside the laboratory. And that's basically what you see with all real laboratories around the world, is that there are things being created in the laboratory, but they struggle to get funding and so on. And as soon as they are capable of making that thing in the laboratory being present everywhere else, they become very, very rich. Like there's one of the big departments in this university is photonics, where they try to use photonics for high amount of computation. So if they actually are capable of creating a photonic computer, they would become way more important to our society, and therefore start getting more funding for whatever they are doing. And that's what you see with like physics and other domains that already got a lot of money, because their past contribution to society, like nuclear physics, where you see this relation happening. So what you see is that as soon as they are capable of moving the thing that's only existing inside the laboratory everywhere else, so that makes the element autonomous, then they become stronger. And that's a natural process that's happening. So you see that laboratories in a certain way create objects. And yes?
Just, sorry,
Okay,
but this is very specific question. Autonomizing, is it your term or did you take it from somewhere?
I actually took it from Latour, because
Okay.
I know it's not really...
That's what I was
I know,
interested
I know.
in. Thanks.
I want to ask again the question that is repeating here, maybe from a different perspective. This enterprise and laboratory, if you go back one slide.
No, this.
No.
This.
Okay. Here there is mobilization system and ecosystem.
Yes.
Where a workspace with a relative state ambiguous separation.
Yes.
And somehow you have your reasons understanding why you wanted to differentiate them.
Yes.
So I want to ask it from the other side. What is the reason to differentiate them the way that you do? Because for me this is the best of all situations where they are ambiguously separated. So what do we gain in understanding of...
From moving to workspace to...
Yes, you created the differentiation and then you continue to differentiate yet in the next...
bootstrapping.
Bootstrapping in relation to what we see in the world?
No, well, for bootstrapping, A creates B and B creates A, right? But the thing is that if you need two separate things to be able to bootstrap. So the question is, where does the bootstrap originate from?
So this...
you mean when you write bootstrapping, scaffold and tools are both necessarily one to bootstrap the other?
Yeah, so what you have is that you can actually fabricate scaffolds separately. You can, from objects, fabricate tools separately. They can exist separately, but like I said, there is an ambiguous relation. But as soon as you kind of create a very specific one that's both a tool and a scaffold, you're capable of bootstrap.
Okay, I think the misunderstanding here is when you write external state absolute separation, it's not really an absolute separation. You want to highlight a certain set of relations between enterprise and laboratory that creates a continuous bootstrapping process of novelty. But it's not an absolute separation. They always work one in relation to the other.
Okay, absolute is maybe a strong word, but it's to make the distinction between the natural ones and the artifacts. You see?
Okay.
Well, I
And
guess
it's the same with the workspace. It's they also say absolute separation, which is a little bit...
Well, I guess what would make me maybe better understand this is that you don't... you just say that the level of separation changes.
Yes,
Sort of
that's
it
basically
becomes...
the whole point I'm trying to make, right? It's that the level of separation reduces in case of the level of agency, while the level of separation increases in case of this workspace stages. That's what I'm trying.
I think this
saying.
is...
But it's kind of just to present it, right? It's.
I think this is something that Weber calls individuation. From the
Is it?
theory of individuation.
Yes, it's the parallels between what you described. You took it into another context, but the processes are very, very similar to what I'm dealing with. A lot of input about it.
So okay, maybe that's a little bit confusing over here. So the whole thing is that I'm trying to understand how differences disappear and how differences emerge, right? And that's a little bit the thing I'm trying to do, and that's why I'm emphasizing on ecosystem, mobilization system, scaffolds to try to understand the intermediate stage of a change in relation. And so you see that on the one hand, differences disappear, on the other hand, differences increase.
Maybe I missed this, but do you describe the process You are describing it from sort of you invent the objects and you put them into some sort of, I don't know, framework, and you describe everything in terms of objects: enterprise, laboratory, ecosystem.
It's not only functions. The essence. The names I've always not always been very happy about, but the essence is it goes from interaction over coordination to control. That's already what we knew from metal systems, right? And I kind of kept that. That's the change. That's the change in function, and it's the same for because this is about what I like to call the potential selection. While on top it's about the potential variation. It goes from fabricating, which is pretty simple and many things can do. Even pure physically speaking, you can see that. The convection cell is a fabricated entity, it's an artificial construction, so it's already capable of fabricating. Bootstrapping, again, that's what I kind of was saying over here, right? Here, it's like below. To create the artifacts, right? So the fabricating, you need physical medium. To go from the artifacts to actually this artificial medium, you kind of need chemical interaction. To go from artificial medium to an agent state, you at least need nucleotides. Higher levels can have higher forms of...
What I was saying, or trying to say, is that I'm trying to understand the process, how this moves, and it's pretty obvious that all the differences are more or less virtual. There is a continuum between all these rectangles. And they are interacting in all the ways. So it would be better for me at least to understand all this framework via the process of how these things happen, not via kind of objectivizing, putting all these little objects and trying to explain what they are, because they are very ambiguous anyway. Sort of didactic constructions just to explain the framework. So do you have the process? Maybe you have it after.
In text, trying to describe.
Not in the presentation.
This is basically how to say that a hook to put everything on, right? To keep track of what is happening. And the basic principle is that these changes happening. It goes from fabricating to bootstrapping to autonomizing. That's basically the important part. The stages between it I can discuss, but where were we? Oh, right, here. So I kind of get at a certain moment to this claim. That's a claim. So like I said, the origin of life requires intermediate stages. So that's also so for the functionality. If you go from fabricating to bootstrapping, that's a change in functionality. So that's an intermediate stage of the process. So first things can be fabricated, and then you see that a selective amount of these fabricated elements is capable of bootstrapping. So that's the intermediate stages required to get to more advanced kind of functions.
This is individuation. It's almost it's an application of a very general term, philosophical term, to novelty. It's makes a lot of sense.
Yeah. So, but for me, the whole research is basically related to trying to understand. I used to call it the primacy, but I know that Francis doesn't like it, so I'm trying not to use it anymore. But I have this novelty model, which is on a higher level, and trying to connect that back to self-organization systems and so on. So what you see here is the first time that this artificial evolution is actually connecting to novelty, where what I like to call inside out, it's by aggregation you get these defaults. While on the other hand, and that's why I need to understand how the separation creates and goes away again, it's how this bootstrapping can happen, where the enterprise creates the niche and the laboratory creates the objects. And what you see actually on the other level is that it's a meta element creating the primary workspace, while the meta workspace creates the primary element. So you see this twist happening. So that's the bootstrap happening. And that can actually more or less be understood by this change in conversion and diversion, right? That's what I'm trying to say. And so then I get to this idea that So, well, for phase transition, you need the meta-workspace, because that's a little bit the hard part. So the laboratories, creating the laboratories are the hard. And therefore you don't get this bootstrap, but you kind of stop with a niche. But to get to a meta system requires internalizing a workspace. So,
what is the primary workspace here? What is it?
A niche is a primary workspace. Like, I also see that with innovation things, everything always first emerges out of a niche. And if you describe evolution of species, you always look at a certain niche. How did the mole become blind? How did the so you look at all the things again to the potential selection, which is the medium, which is the niche.
You don't mean that the niche is a medium between environment and an organism. You don't mean it in this sense. The niche, that an organism
lives in a niche, right?
It lives in a niche, but it lives in an environment, and it creates within the environment a niche that mediates the overall noise of and resources of the environment into its specific goals of surviving. So you do not need. So the niche is also a kind of a mediator, the way that I understand it.
Yeah, I would call a niche a medium.
You wouldn't call it
a mediator?
A medium, sorry.
A medium, yeah.
No.
Yeah. So what I'm getting to is that the thing is that, like in the brain, what happens is that a meta-workspace is being internalized.
It's a nice one.
I love it. It's a little bit more or less because it also has this
Did
curly.
you make a picture?
No, I found it. I really love that I found, because the curly structure is kind of a little bit how it looks in the brain. So there's this. Okay, so the brain has several modules working with several different parts of the information processing, and then there is this global workspace that is kind of connected to all the parts in the brain. That's what the octopus is showing, and it kind of has this structure as an octopus, so it looks a little bit like that. But it comes from everywhere in the brain, and then there's this global workspace. So what
Did you already have a picture of how the global workspace looks like? I didn't think they had an anatomical picture of it.
They have some of the regions, but some of the regions kind of look a little bit similar. I don't think they kind of really separate. I didn't find like they say that it's here or here, but they say it's in that region. So.
There is a region for what is called global workspace?
Yes. And it looks a little bit like an octopus. You need to look it up, it's kind of funny.
Attentional systems, the focusing is internal, it does not, there are perceptual systems, and the attentional works on the perceptions. It does
This is a study from Dehaan, who has been investigating how the other modules connect to the global workspace. And that's the drawing he came up with. And the thing I'm seeing here is that if evolution is capable of creating a meta workspace internally, which it kind of does according to the law of every good system needs to be a model of the system, so it's kind of trying to create a model of what is out there, so that can happen in this global workspace, which in the first place can be a meta workspace, but once it exists as a fixed structure internally, there can be an evolution trying to select the best meta workspace. And that's, in my case, how I believe that you go from meta workspace to the novelty model. But the novelty model is a very specific way of how the feedbacks are connected. And the thing is that Dehaan described it over here a little bit, while Latour describes it on a very different level. He looks at how science and technology is connected to the social fabric, and at a certain. So this first drawing with this arrows going outside is one of his early work in his Science in Action, where you see that there is innovation, there's money involved, there's work versus instruments, objects, arguments. Somehow they kind of create larger circles. That was one of the first things he tries to describe for the Science in Action. But the top thing is what is actually the main claim, and that's why I consider it more a design view on it. It says like, okay, it's wrong to think about science and technology as this isolated element, and then there's a gray zone with society, and then there's society. So he tried to figure out how is science and technology connected to society, and he came to these loops where you need allies, you need this. So you see the autonomization. It's over there. You see it? The second one, the autonomization. So autonomization happens by colleagues. He shows that examples like where there haven't been enough colleagues, research dies out, stuff like that. Or in the case of the Manhattan Project, where another colleague was capable of producing some interesting alternative paths that then finally turned out to be the way to go. Then you see this mobilization of the world. That's a little bit related to the mobilization I've been trying to explain earlier. Latour kind of focuses on the instruments, because with the instruments, the scientists are capable of talking with more authority. They can say, look, my charts tell you it is this. So that's a little bit how the scientist is capable of mobilizing the world. The public representation, you can think about cases like cloning, where the public is very negative against it, or you can think about the internet or social media, where the public is very positive against it. So it's one of these other forces that has a big influence. And then, of course, you got allies. And then the middle, he calls it links and knots, and he cannot really define it well, but if you ask me, that's basically the workspace. And what you see is the connections, how that workspace is connected. And in that sense, it's similar to this workspace. And the kind of the feedback structure is more or less the same. And that's a little bit where I'm ending up to. That's the thing I've been trying to work on for the past 10 years. It's trying to understand this novelty regulation and how that is connected to all things. And so the thing I've been trying to do today is actually show that I really would wonder what it would give if Latour and Clark would actually do a design study, a real design education, and then look back to their own works. Maybe they can actually build on top of what they built and not get to this glass ceiling. And I've been trying to, with the whole presentation, to connect a design thinking to this evolutionary cybernetics. Like I said,
I think you need an action ontology.
I fully agree, but I think that the action ontology needs to be extended with many of the design aspects. But it is a work in progress. Like I said, the reason I gave this presentation is because of the paper from Whatever is Next kind of triggered this discussion in our group. But it's work in progress.
The Whatever is Next
still
paper,
not finished.
what is it about?
Well, the thing is, he goes in way more detail, and I see it with like a lot of cases where also they describe innovation. At a certain moment, they hit this glass ceiling, and then they go more into detail of the things they know way better. In this case, it's going back to...
I know what you mean, but this specific paper, what is its subject?
It's about seeing all the cognitive and brain activity is made as a big prediction machine.
Oh, that's that paper, but
yes.
Yeah, but what he basically did is he switched to a different topic.
Yes,
this is what a different topic.
Mixel is disappointed about.
And it's not you're disappointed because you expected that he would develop the extended mind thesis. But on the other hand, what he did there was interesting in C.
It's interesting in C, but it's not. I mean, like I said, for both Clark and Latour, I found their second book a real design book, a design of the thing of intelligence, the design of science and technology. And I was looking forward for the next book so we can really start doing stuff and changing society and understanding intelligence.
I haven't Latour, but with Clark, I also have this kind of ambivalent feeling that he brings in lots of interesting stuff, but when it comes to really clearly stating the whole conceptual framework, it remains misty. It's kind of lose their graspability.
I'm finished.
What about Latour? I mean,
Yes.
Acto network theory. What's wrong with that? I haven't read Pandora's box, so I'm not sure. But if it's the same way, he just talks about different things. So why do you say about
No.
the glass ceiling?
If you just look at the view of the book, like if you look at Pandora's box, there are many design structures and
Pandora's hope.
Pandora's hope.
Pandora's box.
Box.
Yes. Okay. So, but if you look at it, he actually tries to work on. So, like I said, the difference between the system view is how things are, and the design view is about how things can be. You see that in both the supersizing the mind and in Pandora's hope. Why did I write box?
Because originally the idea is Pandora's box.
Ah.
His Pandora's hope is a
the last thing in the
variation
box.
on Pandora's box. Yeah.
The hope is the last thing in the box.
It's not a variation, because in the mythos of Pandora box, inside the box, after you open the box,
yes,
and
the last thing.
all the nasty things went out,
Yeah.
there was one thing which was left inside, it was the hope, which was to counterbalance all the...
So, and after...
It's the worst thing.
It's the worst thing that
Depends on interpretation.
But
So
different interpretations.
In the story, it's about belief and trusting it, and then opening it again. Although all the bad things came out, so that hope can come out and change everything. So that's why they call it Pandora's hope, because basically that's a little bit what Latour tries to tell in that book. It's okay, it's going to be messy and it's going to be crazy what I'm going to tell, but there is hope in the end. That's basically what he was trying to say in that book. And he starts with the whole idea of how is science embodied in the social fabric, which is kind of very related to Clarke's idea of embodied mind. So they both go to this embodiment. And I really have the feeling that with supersizing the mind, I'm almost far enough to start doing and building things with it. And the Pandora's box was also like, we need just 1 or 2 steps more and we are capable of starting creating stuff with it. And then if you then, like the actor network theory, I've read the book 3 times and I still don't know what it's about. It's basically, for me, it's pure rubberish. How do you say that?
At least for Clarke, it's a little bit unfair, because whatever next is not in the line of work that...
Oh, there is a connection. No, there is a connection. Because in the end, he kind of tries to show that you need the social level. And there is some connection there to the extended mind, but it's like...
Yeah, it's a very
sideways.
He went sideways.
I think it's an important, whatever next, I think it's an important review paper.
Review paper. Well, the thing is, I've seen that with innovation papers as well, books as well. They describe something and I think like, yes, that's interesting. Now the next thing, that's now the hard thing. And then in the next book, they kind of go back and they do the things they knew better in more detail and do very good review things. But I kind of have something like, you had 1 step ahead, go try to make the next one, although it's very hard.
No, but it's, I mean, it's part of the whole scientific enterprise that you grasp something, you give some examples, you have an intuition, and then you're trying to put that intuition into a formal model, and you see that actually your intuition is not clear enough yet, and you're not yet ready. And I think that happened with both Latour and Clarke.
The question I'm having is, are they at the right place with the wrong tools?
It was too
And
general for me.
if they would, okay, I understand that if design thinking is still very, I've been on it for years and I still don't grasp it fully, but I think it could help scientists a lot in their work to get, because that's basically what I try to do with the share. This is the system view of the share. This is the design view of the share. It's a very different way of looking at the same thing.
I read about actor network theory, not Latour, but by other authors about it, and what I read about it, it seems kind of like an obscure version of the action ontology. Kind of attempts to build an action ontology without quite grasping what action and actors are.
Questions?
Yeah, an infantry.
But I hear this criticism, sort of, these books of Clarke and Latour, they get worse than they try to produce something concrete.
Yes.
And this is a little bit not fair. For example, I would say, regarding action ontology, maybe action ontology is needed for that, or maybe it's better, but then it should become concrete. I hear a lot about action ontology. I hear during the discussion, I think I have a feeling what it is about, but it's difficult to understand what
Yeah, we
is
need
the
to
concrete.
It is difficult. I mean,
So when people try to do that, this
the
is a very
goal of the
difficult thing.
problem is that we are addressing a very complex domain that requires completely a new paradigm. The mechanistic reductionistic paradigm doesn't work.
Yes.
That's clear.
Yeah, but you need something to hold on. And like, if you think about this case of the Eather, what you see is that they had things to hold on. There was this specific event, and then they start creating artifacts with it. But we are still, I mean, we are still not there yet, I guess. We are still not there yet. We don't have those clear events that shock our worldviews. I mean, it's very hard to. I mean, in quantum physics, that's the whole thing.
I think in this case, the biggest confusion is the mind-matter distinction, the dichotomy. Everybody is kind of assuming that there is matter and there is mind, and then when you speak about cognitive processes where actors or people are interacting with tools, or interacting with environments, or interacting with objects, and all that is one big network that's self-organizing, then people kind of lose their guard, because they tend to look at the ones as minds and the others as matter, but actually they are playing the same role, and
observer in reality, more general, but the same.
And that's why you need the action ontology, because in the action ontology there is no a priori distinction between matter and mind. There are actions, there are agents, and an agent, if it's kind of more sophisticated, you call it a mind. If it's kind of more simple, you call it a physical system. But there's not really a difference. But you need the meta-system transitions to be able to explain how agents get more complicated. And you have tried to explain meta-system transition in one way. I'm more inclined to look at it in terms of the chemical organization theory, which is actually similar to your example with the citric acid cycle. Which is a kind of a closed network of reactions producing elements.
I've actually, based on these two graphs, but I will bring it next meeting, on these two things.
I suggested to you to represent that with chemical organization
I've
theory.
spent half a day with Thomas. Presenting this as chemical organization.
Yeah, but maybe he didn't grasp it all, because I gave you an example where it came out quite nicely. I think it's really not difficult to express that with chemical organization.
The top one we've tried to do, and like
I would go to the bottom one.
Yeah, but the top one is more interesting, because you want to see the restrained perturbations, how they are capable of creating new things. And trying to define that as a chemical organization was pretty...
No, why not the left one? I mean, just replace your triangles and squares, etc. by letters, and your arrows are arrows, and then you have A plus that turns into that.
But that's trivial.
Yeah, but then you have to
it's
sort of
not
define
trivial
boundaries.
because the closure is not trivial. You can easily put them into arrows. But the chemical organization theory says here you have a list of arrows, that means reactions where you have A plus B gives C plus D, E gives F plus G, H gives I plus J, and so on. And now, is that closed? Is that an organization? That's not trivial.
Well,
if it is an organization, then you know.
That's my focus. My focus is novelty.
Well, the novelty is there that if you have an organization, it becomes a closure, it becomes a higher order system. It's like the origin of life.
Well, we spent
the
a lot of time.
autocatalytic cycle is a simpler version of a chemical organization. A chemical organization is not just one cycle. There are all kind of reactions that form a network that behaves like a cycle in the sense that everything is being recycled, but you can't just say why the cycle is. It's a richer structure than a cycle. Mm-hmm. But it has the same function.
But it
and
was
the cycle is what creates the higher order system.
It was interesting to see that with Thomas we kind of were expanding the chemical organization theory to make it fit with that model, and it turns out that some of the more explorative ways to extend the chemical organization theory could be used to explain it. I think we still had a few things to...
The boundaries are not well defined in chemical organization theory. There, Thomas had developed some system with, how did they call it, vessels, reaction vessels, where some things could diffuse into some reaction vessels but not in others.
Yeah,
so that makes it more complicated if you want to describe the topology of
it. There was last one.
I think that there is the work of John Holland in the
This
Signal
process
boundaries.
he kind of starts using, but I need to look back at my notes, but a conditional reaction,
Yeah.
where you can actually say that this is actually going to be, so a normal perturbation is going to a simplified perturbation, depending if the perturbation is strong, if the force is strong enough to penetrate the plasma. So this kind of stuff.
Yeah.
But I'll bring it
That's
because
that makes it more complicated if you look at the boundaries. But
I'll bring
in
it
this
next week.
case, in the lower case, the boundaries are not really necessary.
I think for a general, to describe really general
This is strange.
processes, you need to relate to boundaries as
Just
well.
adding one. Yeah,
It's,
well,
it's really strange bug.
Click on it.
What did I hide? I hide words.
no,
No, I hide words. Look, if I view
No,
the
the
word again,
one
then
is
it's
not-
over there.
So it comes from where
it
yeah.
comes from
So it
word,
comes
yeah.
from word, and if I hide word, then it's
Yeah.
okay. Bugs.
You need the boundaries.
Finished?
Well, we have some more questions.
Question. Go ahead.
Question is some comments. Maybe there are a lot of questions, but there are some comments.
Okay.
First, the first comment is that this was the most interesting seminar for quite a long time.
That's good.
Yes,
Thank you.
It was really fascinating talk. I find a lot of parallels, specifically in the first half, to the work I'm doing on individuations. And I think, at least in some in the discussion about the formation of workspaces, etc., there is at least one chapter in the book of Deleuze and Guattari on Thousand Plateaus, which deals exactly with this, but it's quite complicated because they have really overdid it with the jargon that they are using. But if you read it a few times, there is some kind of very interesting stuff there. So,
Right, if you could just
Yeah,
show me the things I
yeah, I can. I have. It's a chapter that I have read and I have annotated, but even with the annotation, it's not.
But you know what? I can read it and then we can have a discussion.
Yes,
That's
yes,
gonna be easier.
that might be interesting. So there are a lot of parallels, and I think, as Francis said, it's look, not everything that you said is clear, and you know.
Yeah, that's a bit of problem that I've been working on
And
the way
cut
to
and
much longer.
accurately cut into rectangles, etc.
No.
But the overall presentation is thought-provoking, and because of this, it's interesting.
Yeah, he's asking very important questions, but his definitions, that's always.
Yes, and I always
big
appreciate. Sometimes I appreciate things that you say many things. They are not all of them clear, and they are not arranged into a very clear and concise organization. But they invoke thought, and they become a ground, like a workspace or a laboratory for innovative ideas.
Yeah, that's
So, in a manner of speaking, your presentation is a kind of, I don't know if it's not an enterprise, it's a laboratory.
It's a workspace. I wouldn't even
It's a
call it a
workspace.
laboratory.
It's a kind of a workspace.
Yeah. That's the goal. Yeah.
It's a workspace, and it's nice. One specific remark is if you can go to one of the first slides with the agent autonomization.
Say stop.
Yes, here. From artificial medium into an agent, I think that I would suggest that it will be more accurate to say that the artificial medium differentiates into an agent and an environment. Because agent and environment always come together. You don't have an agent that operates in vacuum.
No, of course.
So when artificial medium is differentiating, it differentiates into an autonomous agent and a background, an environment upon which the agent is performing its actions, perceptions, etc. This is just a suggestion.
No, I agree. No, but I understood that this separation and then this separation, kind of with this, like here, both of them are. It creates seemingly more confusion than.
This one, the differentiation between enterprise and laboratory, I believe that it is inspired by a lot of things that you read about in innovations, etc. So maybe we don't have the whole picture of vocabulary, formalisms, etc.
For me, it's clarifying, but clearly it's.
Anyway, it's very interesting. So that's more or less.
Well, my comment, I think we already touched this, is that it's not fair to. I mean, what we were told about your presentation is kind of you are in the stage when you talked about Latour and Clark, the stage which you like the most, and when they tried to formulate more specifically what they think about the systems, it went worse for you.
Yeah.
But for me, the attempt to formulate is important. So if you have bunch of stuff which gives you a lot of ideas, it's not yet finished. You have to try to formulate, and that's probably more difficult.
But the thing I saw is that
enterprises.
They kind of have this intuition. It's not yet well formulated in their first book, like for Andy Clark, it's the case with Otto who has Alzheimer's. That's just one case, and then therefrom he distillates the whole thing of extended mind, and it's a lot of there's a lot of criticism coming against him. And after many years collecting all that criticism, he creates this book, Supersizing the Mind, which is basically formulating more clearly the thing that was in front of it, and then whatever next is deviation. And that's the same what I have with Latour. It's if you look at science in action, it got a lot of attention with it, but also a lot of criticisms against it. And I find that Pandora's Hope is actually a formulation of many of the problems in way more specific ways. And so that's what I liked about it, because I had the feeling as an engineer, from a design perspective, that there's almost enough clarity for me to start doing things with it. And if I then look at the actor network theory, he's very vague. He suddenly becomes extremely vague again.
Is it enough clarity to start doing something with this framework you presented here?
No, that's what I said. We've been working on it for 10 years, and we are definitely not there. I actually just decided with Francis to take it out of the PhD and put it into an appendix, because we simply are not capable of closing it, because it's. But it is a problem of not having. I mean, it's easy if you have a compiler or a concrete problem where you can bounce your thing against. Like you try it out, and the machine tells you how wrong you can be or which parts are correct. But if you don't have that, it's really out in the void, and so far the only thing I had to bounce against is Francis. So we have been we've been spending many coffee breaks to discuss this.
I'm waiting until he finishes before I start.
So I got a successor for that.
Yeah, I think it's very important. Because if you come up with something,
really innovative. At first, you don't know if it's worth anything or not. What you do have is like a gravitational well of the current dogma that attracts. You say, okay, now you have to to defend a PhD. Okay, this, if you try to formalize it, what Victor says, if you try to formalize it in terms of the current dogma, you will get either a confusion or something that you would not like anymore. So it's both very, very bad options. And yet, in order to create something new, and I feel that we are touching in all our discussions across the years, and also this work and the work that we do, it's really touching something which is outside of the current dogma. And it's really difficult. It's really difficult to promote it and gain, as you gave this diagram of Latour. You have to have colleagues, and
yes,
this was nice. And the public representation, mobilization of the world, the autonomization, all this. It's very. I think it's very important.
But this is his first thing that he created.
The links.
And this is more. In a certain way, this is more vague than this. So this is like a stronger formalization of what is exactly happening.
Yeah, in the inner circle there is links and nodes. And the first metaphor or analogy that came to my mind is a pot. You come to cook something not according to a site. You put all sorts of things and you cook. You don't know exactly what are the relations between everything and everything, and then after cooking some time you taste it. If it's good, you try to remember what you have done and how you did it, and try to repeat it again. But the links and nodes is exactly the stage that you are in this work, because it's not obvious how to connect everything into a new coherency. Okay. And if you fall back to the existing coherency, it will not be better. Most probably you will lose the magic that made it interesting in the first time.
But you need to go there.
You must go there eventually, yes.
Well, I'm trying to. I mean, I really don't like his description of links and nodes, and I really like the global workspace.
This is
when you see
this is nice.
Which one is nice? On the right or? Yeah, but I like the.
No, actually, the octopus is also a kind of an homunculus because it has a brain and it's.
But
yeah, it shouldn't have a brain. Just
but the interesting
you should check the figures. I was surprised about it. It looks a little bit like an octopus.
But what I've read, I think, about octopus is that it has a kind of decentralized system of moving these 8 legs or tentacles.
Yes.
So it's not centralized. It's kind of have different.
Not completely centralized.
Which
is
its
eyes, I suppose, will be processed centrally. It's input from its eyes.
Yeah.